Okay, if I say log 5, what base is it? Base 10. Even though it doesn't have a base 10 written there, it means base 10. All right, what if I couldn't write subscripts, like on those flashcards we were looking at? How would I write log base 10? Well, I'd put log 10, 5. And that would imply that the 10 is kind of like really close to the log, that it's the base of the log. Okay, so you got to know that if they can't write subscripts, that's the way they'll write it. But if you can write subscripts, you really should put a base 10 down there. But if you don't have any base written at all, that means the base is base 10. All right, next thing. If you know these two are equal, if the base and what that's called the argument are equal, do you know what the answer is?
1.
1. It's 1 because the 1 is the exponent on this 10. If that exponent had a 4 on it, for instance, then the answer would be 4. And just to clarify, that means you can replace this entire thing with a 4. So it's a lot like canceling. It's like this cancels out and the answer is 4. I don't know if you like that way of thinking of it better, but this whole thing is equal to a 4. All right, so if I said log 10, what's the answer? 1, very good. Because the base 10 is assumed, and if this is really the same as that, then the answer is that exponent. All right, next little thing I want to teach you about logs is log base 3 of 5 squared. Again, you do not need to know this for the test, but that 2 right there can be taken off and put down here. And I'll explain why by showing you another little property. All right, here's another little property that's important. If I have log of 5 times 2, that in log world has all different rules than regular math world does, would be log 5 plus log 2. All right, now some of these you're not going to really believe me unless you try it yourself. So would you grab your calculator? Grab a graphing calculator. If you don't have one, hurry up and borrow one of mine, make it fast, leave a shoe, or actually, I'll let you just borrow it without anything this time. But start bringing your own. If you just have a one-time oops, it's okay. There's another one left here. Okay. So, would you agree log of 5 times 2 is the same as log of 10? Because 5 times 2 is 10. Okay. So then, what is log of 10? We just did that 2 seconds ago. What is it? It's 1. Test me. Try it. Log 10. Type in log 10 and see if it really equals 1. It does, doesn't it? Okay. Then, I just said a second ago something kind of crazy. I said that log of 5 times 2 was equal to log of 5 plus log of 2. Well, figure out what log of 5 is. Figure out what log of 2 is. Do they actually add up to 1? Yeah. Mm-hmm. All right, so now hopefully you'll believe me that log of 5 times 2 is the same as log of 5 plus log of 2. Anybody want to take a wild guess what happens if I have log of 5 over 2? And yes, it'd be the same as log of 2.5, but that's not what I'm trying to say. Who said to subtract? You're right. That means log 5 minus log 2. You'll get the exact same answer as if you do log of 2.5. All right, so that's something special in the log world is you can split them up. That's called expanding. I'm teaching you pre-calc right now. Seriously, this is pre-calc. This is not super hard pre-calc. This is easy pre-calc, but it's something we teach in pre-calc. It's not that hard. All right, so we of course get more intense ones. Sometimes we do like this. And I just taught you something 2 seconds ago that would tell you what to do to finish this problem. What did I say about that too? Put it in front. There it is. That is a more typical pre-calc question. And then there's the answer to it. You split it up because it's a subtract and divide go together, and then that 2 that's up there can go down in the front. And I want to prove that that 2 up there can go down there. If I have log base 2, log base 10 of 2 to the second, do you get that the answer is not 2? Because this is a 10, and these are different, and so the answer is not 2. You get that? All right, so then let's go back here and say, if it's log base 10 of 2 to the second, that's the same as log base 10 of 2 times 2, right? Isn't that what 2 to the second means? 2 times 2? And now I just told you what you could do with that, right? You can split it into log base 10 of 2. What comes next? Plus log base 10 of 2. See, we split up the multiply into this and this. The 2 parts got their own log. It's called expanding. Now, if I've got 2 of the same thing, see, these are the same thing, can I just put a 2 in front of it and say 2 log base 10 of 2? It's 2 of them, right? That's why I could have, right off the bat, taken this and slapped it down in the front, see? Because you could get there a long way if you want to, but it's a lot easier to just know that if it's an exponent, it can just go right down in front. All right, one more little topic I want to cover is if I have log base -3 of 10, that is not allowed. You know what's wrong with it? Can't have that negative there. Can't have a negative here. You can't have a 0 in either spot. And 1s are okay in one of the spots, but not in the other. There's 3 spots, A, B, and C. A and B are what we're talking about here. A and B can't be negative. They can't be 0. They have to be positive numbers. And there's one more restriction, and that's the 1 can't be in one of the spots. I want you to take a guess. And don't just say, well, there's 2 A and B. I got a 50-50 chance. Try to figure out logically, why do you think you can't have a 1 either in the A or in the B? Come on, use your big brain. What do you think?
Because A, like, no matter what it's, or it's 1.
If A was 1, yes. So if I rewrite this as 1 to the C is equal to B, you're saying no matter what exponent I put there, what will the answer have to be?
1.
This would always have to be a 1. So what if I have like a 7 there? See, it's all of a sudden it's impossible, isn't it? So what are you trying to say? What won't work? 1 in the, what's this spot called? Base. So therefore you cannot have a 1 in the base. You are correct. Now, can you have a 1 in the other spot? Yes, you can. I'd like you all to put it on a blank page. Stop whatever you were doing. And put in a blank page and write this. Log base 3, 1 equals x. Now I want you to rewrite it as an exponential. Tell me what you wrote.
3 to the x equals 1.
Go ahead. 3 to the x equals 1. You're right. So there's only one possible answer then for this. What is it? 0. What if this had been an 18 here? 18 to the... So what do you think the answer is always going to be to this problem? So if there's a 1 in the what? In the argument, then the answer will always be 0. So what's log of 1? 0. Doesn't matter what the base is. All right. What's log base 63 of 1? 0. And yes, you could take a while, figure this out. Go, this equals x, that to the that equals that. This is the slow way, but it works. Oh, this has to be 0. Okay. So we've learned a few things about logs. I now want you to go through those cards and see if you can do every single one of them. I'm gonna pause for a second while you flip through those flashcards. So were you able to get through the cards, or was there any of them that you feel like I should explain a little further? Because I will. Yes, tell me. Change of base property, okay. How about this? Do you understand what to put in the calculator if I asked you for log base 5 of 9? Do you know what to type in the calculator? Log 9 over log 5, exactly. And that's what they wrote, except with variables. And they put in a base on them, but your calculator is going to know that the base is that it likes is 10, but it could have been any base in the world, so they put a variable there. So the change base property is just saying that you can type this into the calculator as log 9 over log 5. I'm super simplifying it there, but that's... Do you get that now? Okay. Any other ones you should clarify? Yes? Okay. That means if I could write with subscripts, that would be this way. Log base b of xy. Remember just 2 seconds ago we talked about changing a multiply like this into splitting it into 2, which would be log base b of plus, yep, and I bet you that's what the answer is. Okay. Any others you want to talk about? Good, then you get the basics. In fact, you get more than the basics now. You're getting into pre-calc level of understanding how these work, which is cool. So now today's lesson is going to feel easy. Here's the type we're going to be doing. Look at this slide on your notes, please. Do you know the 4-finger swipe yet? On there? Get into any app, and then like you're in an app right now. That would have been okay. And then if you want to move to the next thing, you just use 4 fingers at the same time and swipe over. So like say you're in Flashcard Lib, and you want to get out of it to some other app. Now you're in that app. Now you're in that app. See what I mean? So then I'm talking about 4-finger swipe. That's what I'm talking about. Okay. All right. So on last night's assignment, we did this kind. We're done with that kind. That's the new kind. And these are actually the easiest kind. So it's a nice, easy day today. All right. Here's a typical problem. Flip to this one, please. Log base 2 of 8 equals x. Now, could I rewrite this the other way? 2 to the x equals 8. Yes, I could. 2 to the x equals 8. It's right there. And then you just look at it and say, oh, well, if I rewrite the 8 as a 2 to the 3rd, then these just have to equal each other. But I say there's a faster, smarter way. Couldn't I just make that 8 into a 2 to the something? And if I did, then I could just use that property. Because as soon as that 8 becomes 2 to the something, what's my answer? 3. Done. See? Isn't that pretty fast? All right. So I want you to try this one. On a blank page, insert a blank page. Log base 5, 125. If you haven't memorized this, you need to have memorized 125 is really what to the what? 5 to the 3rd. So the answer to this is 3. See? Easy peasy. All right, I want to stretch your mind a little bit. If this is really 5 to the 3rd, didn't you say, Mr. Server, that you could take that 3 and stick it down in front? Yes, I did. Do you get that this answer would be what? And then you times it by 3 and the answer would be? So it still works, doesn't it? Sweet. Okay, so let's try one more. Log base 8 of 64. Because you could rewrite 64 as 8 squared. All right, let's make it harder then. Let's say it was 1 over 64. If you rewrite this as 8, here I'm going to rewrite this log base 8 of 8 to the negative 2 now. Does that work? How about this? Whenever you're doing these kind, you should say to yourself, take the 8 and square it, which is 64, right? And then the negative does what to it? Flips it. So it is right. So what's the answer? Negative 2. You can. In the exponents. That's a good question. The question was, I thought you told us we couldn't have negatives. You can't have a negative on this or on this, but you can have a negative on the exponent. All right.
What if we were trying to find x? Then would it have to be 1/2?
There is no x. If we wanted an x, we'd say equals x. And then I'd solve it, and the answer would be negative 2. This number can be negative. Just the argument and the base cannot be negative. All right, moving on. Everybody get to this one, the one that says try number 1. And then try it. Shh, stop with the yawning. Get to work. Get to the right page. Muy rápido, por favor. All right. Do you have 1/2 to the x equals 32? That's an okay way to do it. I wouldn't do it that way, but it's an okay way. I would just rewrite that 32 as a 1/2 to the something. Because see, then my 1/2s would match up, right? So if I could put that as 1/2 to the something, I'll have it. What's the something, though? Negative 5 is correct. And the answer is negative 5. So what just happened there? 32 got rewritten. 32 is the same as 1/2 to the negative 5th. Why? Because let's say I just took 1/2 to the 5th. Do you get that that would be 1 over 32? And then all I got to do is this to make it flip and make it regular 32. Okay. Move on to this one. Solve log base 5 of 125 equals 2x minus 6. Holy crap. This is seriously just about as hard as we do in pre-calc. But it's not really that hard. If you could only rewrite this as a 5 to this something, then this whole side would turn into a number, like 7. If that whole side turned it into a number, would make it a super simple equation. So you rewrite this inner circle as 5 to the negative 3, and then you got log base 5 of 5 to the negative 3. And remember what I said about this? That you may like the cancel thing better? If this just cancels and the answer is negative 3, now the answer is negative 3 equals 2x minus 6, see? And I just solve it. It's super easy. I take it to mean that you girls figured it out? All right, good. All right, so then I add 6 to both sides, and I have plus 6, and I have 3 equals 2x, and I have x equals 3 over 2. All right, moving on. This one. Last one I'm going to do with you. Stay with me, and then we're going to be working on homework. Because this one's a little weird. All right, would you start by rewriting this one? This one I would not try to do that shortcut way I was showing you. This I would rewrite. X over 5 to the 3rd equals 64 over 27. Now, there's all kinds of complicated things you could do, but remember what you're really trying to do. Solve. To solve, you're trying to get the x alone. If I could just get rid of the 3 and the 5, the x will be alone. Just don't get over like complicated. You just got to get rid of that 3. How are you going to do it? Yeah, put it to the 1/3 power. And now I'll just have to get rid of the 5 at the end. And I'll be done. And then this and this cancel. So it's x over 5 equals 1/3 power. I can do that in my head. What is it? 4/3. Because third root of 64 is 4. Third root of 27 is 3. And now on this one, some kids like to cross multiply. Go ahead, but that's the slow way. What's the fast way? Times by 5. Just times by 5. And I times by 5 on both sides. And this gets it rid of all down to x all at once. Done. Because 5 over 1 would be 20 over 3. All right. I think you're ready. Your homework. Find it. It's under Schoology for today's date, which is the 10th. Hard to believe we're almost, see, you could round it to almost halfway through April. Holy cow. And then all we have left is May. And then June is pretty much, it just flies by. So it seems like you almost have a month, only have a month left, sort of, in a really dreamy kind of a way.